Guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. This is literally one of my most favorite amps ever made. It's made by Golden Eagle. This is the 377 XL. They make a 1x4 version, a straight 4-pill, and an 8-pill and a 2x8 version. And this is the 2-pill. They make two versions of the 2-pill. One had 2290s in it. This one has the 2879s. Now, I have not played with this one yet. When I first seen one of these, it made me go, I don't know if you remember a couple years ago I took a lot of crap because I came up with this thing. I thought I invented it. I really did. I thought I'd come up with this thing called mirror board technology. When I first got my spectrum analyzer, you guys, I went hog wild with it. I tore that. I had this old 2x4 amp that I had, and I tore everything apart in that damn thing. I must have disassembled it like 50 flipping times. I changed everything and I watched. Oh, and the thing I was studying when I tore it apart was, one, how to get the most power out of it, and two, how can I make it the cleanest that I possibly could make it. Okay? So I explored two before I explored one. Two, I was all about, okay, I gotta make it the cleanest thing in the world. Because at the time, the little hater clans that were out there while running around, you don't know what is Darren, you didn't know, can't know anything, it's Romano. You're right, I didn't know anything. Still don't know anything. I'll be the first one to tell anybody that. I don't know squat. But I have put a little bit of time in studying a couple things, and this is one of the things I spent a lot of time on. I wanted to make the cleanest solid state bipolar push-pull amplifier I possibly could. And I went crazy with it. Change turns here, change turns there. Took a million notes. I'd do one, and I did the Herculean way. I'd change one thing at a time and studied it and see how it affected the circuit. And I'd change another thing, change something back, and then change this around. In my process of discovering things, one of the things that I tested was ground distribution, internal placement. So how much of a difference did it make when I started adding ground to the circuit and where I put it? And one of the things I did is I took a piece of phenolic on the inside of this amplifier and I laid it down between the transistors and soldered it. Because at this point it had dawned on me in my big amplifier building career, because I'm not going to lie, there's a lot of amps out there from when I was a young man that are running around with braid across the top of the transistors. We figured out a long time ago in a galaxy far, far away that if you put braid across the top of the transistors on most Texas Star amplifiers, they'll produce about 10-15 more watts and they'll pull less amps. Well, those results are indicative to a couple different things. The inadequate amount of ground distribution inside most amplifiers, one, and two, those transistors are all going to get hot. The main thing that causes the transistors to perform better is that they're able to get a unified field of ground reference across all of the tabs on the device. So, knowing this going into, okay, I've got a spectrum analyzer, I'm going to look at my signal before, then I'm going to make a change inside the amp, and then I'm going to go look at my signal again post. And what we discovered was, when we put the piece of phenolic down between the input and the output transformer, that there is a little bit of crap that comes into play when you have the output winding and the input winding on the exact same plane. Otherwise, they're completely level with each other and they can see each other. Okay? What happens, there's a little bit of leak harmonic that goes, because you have an antenna and you have an antenna and an antenna. You got to think about it like that. It's not technically how it works, but for the sake of this discussion that we're going to have, you have a transmitting antenna and a receiving antenna. You can think about it like that. Really what's going is there's a field flux that takes place between the primary transformer. And when the secondary transformer is in a state of flux, it can be influenced by outside field signals, okay? Otherwise, a little bit of RF can leak from here to there. It's not perfectly in phase with here, but it gets transmitted as garbage as a second and a third order harmonic, okay? Now, what we figured out was these are my transformers. They're built this way for a specific reason, not for aesthetics. This is what the standard transformer looks like. Sorry, it's a little rough. This is a pull. I don't use these anymore. When you have primary and secondary on the same plane, you have that field effect. Transmit signal, bleed signal. But where this sits on a different plane, it doesn't take much. With that little bit of height, allows the fields. One's going this way, okay. The fields aren't directly parallel to each other, so they're out of phase with each other just a little bit, and you can cancel that little bit of signal bleed. Now on the upside of that, instead of having to take my power wires and go over the top of the transformer, I can now go on the bottom side. So you've got a ferrite bead, and then the wires land against ground, and it makes them that much more resistant to having RF want to walk back up the power leads and turn that into part of the actual circuit. But the main thing was I wanted to get rid of, it's literally that much distance in height that we're talking about. And I wanted a little bit higher quality of ferrite material that wanted to have more control. I don't want to put it that way, because then people can go and they can run out there and they can run their mouths and say somebody said something negative about each other. I wanted to have more control over what I was producing at that time. So, but for a short minute, for about a year, I ran around and I said, man, look at what I figured out. It makes the amp cleaner. It does. It makes the amp monster manually cleaner by putting this board in here. And then what happened is I pulled open a Texas Star that was made in the 70s. And it had a piece of phenolic that was soldered in here. It didn't go over the top of the transistors, it was just soldered in here. Now the phenolic, when I put this thing in here, it allowed me to pick up more ground reference, so therefore the amp put out more power, but the side effect that wasn't foreseen was that I was making the amplifier cleaner. Those three things happened. It happened. Okay? So I went out there like I was, Moses on the mound, right? These are the 10 commandments of amp building. Man, them guys lost their brains over that. Not necessary. It's not necessary. It's out of. When you strap across the top of the pills, you get the added benefit of better ground distribution across the tabs, so you can get a little bit better current flow. But the braid traps the heat to the top of the ceramic. So that ceramic, you want to try and keep it as cool as possible. You don't want to provide a metal heat sink on top of the ceramic. The idea is the ceramic is going to take whatever heat is passed to it and then instantly wick it back down to the foot of the transistor again. So if you take and put a heat sink, otherwise i.e. a piece of metal, usually copper based, which is going to absorb heat very quickly and it's going to hold on to it, what you're doing is you're causing the lid, the top of the transistor, to have an excessive amount of heat held to the top when it shouldn't be there. So once I figured that out, I wanted to go to something different, and where I went to was the board, the phenolic, and that in turn led me to falsely believe I invented something. Look, there is nothing new underneath the sun when it comes to this. Nothing new, nothing. The guys at Motorola spent a lot of very, very well high-paid dollars in the 60s and 70s figuring this out, long before any of us guys have come along, and it was basically a rediscovery of technology. In this particular application, they put this in here because it makes the amplifier cleaner, and it also, secondary effect, carries more current across the transistors. If we look, let our brains slow down and look, we will see a lot of technology inside of this thing that everybody runs around screaming and carrying on about. Remember, this was built in the 80s. Most of the guys that are in my age demographic today, we were just trying to figure out girls and boobs in the 80s. Because God knows we weren't paying attention in junior high. Look, double stacked metal mylar capacitors. Metal mylar 120s. This is 1,000 puff. The turn ratio looks really familiar to a lot of us too, doesn't it? The biasing circuit, low diode, big diode. Now what I think is interesting about this is that it's front fed. Okay. I had to do that on the 50 volt bipolars. I had to front feed them, and that was the only way I could get the transformer to flux the way I wanted it at the time, based with the knowledge that I had in my ear holes at that time. Then I got taken to the Skullcracker School of Knowledge, my mentor, my teacher, and my friend. And then it really came into fruition when I went to the Shockwave School of Knowledge. And there's a gentleman who's back east. His name's Donald. Great guy, stupid smart. Has spent more time thinking about radio than any 10 other people ever should. Took me underneath his wing and really explained to me the finite technical details of amps and certain applications, certain points. So I got a lot of different teachers that taught me a lot of different things, and some things I self-taught myself. Okay. Now the burden that I carry on my shoulders today is that I've got about 4 or 5 guys that I work with, and each one of them I'm teaching them something different, and teaching them a different way because that's the way they need to learn. It's fun. It's a headache in the same breath, but I love it. So, needless to say, this amplifier here will probably run with most anything that is built today and probably outclass it. And that's why I love these boxes. I'll never forget I hooked up a 1x2 version or 1x4 version of this thing, and it did over 1,000 watts. And I went, what? And so let's slow down and let's take a look at it. I was like, wait a minute. Look at all the stuff they have hooked to the back of this thing. They got a protection diode, isolation. We're going to use the back of the transformer as our distribution bus instead of having that set off some other place. We're going to have another induction coil going to ground for better filtration and clamping of the... There's an amazing amount of really cool tech in this. So all the guys that watch this that are amp builders, I want you to think about this. This precedes Dave Made. This precedes a lot of different companies. And a lot of different people that run around and say, Dave Made did it first, or so-and-so did it first, or the Tooth Fairy did it first. Not specifically picking on Dave Made at all, but there's a lot of tech in here that did not exist pre-it. And when this showed up in this amp, it got replicated a lot of different places. These are very hard to find. Usually when they show up here, they're in really good condition, because in their day, these amplifiers cost almost 3 times the amount of money as their closest parent partner, which was a Palomar at the time, or a Texas Star. But the performance is where this lies. I'm telling you. The only thing I don't like about this is the size of the relay. Other than that, this thing is a work of art. So if you have an opportunity to look at one of these things up close and personal-like, absorb as much information as you can off of this. 10 ohm, 10 ohm. But look where they're placed. But then again, we've got our 10 ohms here. Now you got to ask yourself, how does that affect the transformer, and why is that being referenced there? Okay. Here's our nice induction coil choke. And our induction coil choke. This is pretty much the way I build my bias circuit, but I wrap my circuits by hand. Okay. Have a choke, then a secondary choke. Then you put another choke after your load cell resistor. Because remember, this will still pass 12 volts unless this diode's here, because then the diode's going to let the voltage leak back to ground or return to ground through the diode. And the resistor is going to act as your load shunt, and that's what's actually going to reduce your voltage. But that diode is what controls the quantity of voltage that is going to be allowed to go through. We can go on and on and on here. This is an amazing little amp. Little disc capacitor. Another little electrolytic. So it's almost an affront to me when somebody says that I copied so-and-so. It's like, no, I straight out studied one of these and then figured out how it worked and why we wanted to do individuals. This look very familiar to somebody? Disc capacitor, electrolytic, little tantalum, load diode, bigger load resistor. Think about it. Food for thought. This one's here because it fell in output power. Flat out fell with output power. So we're going to go in here and figure out which one of the capacitors let go. It's that simple. We're going to give it a power wire upgrade, give them new leads on the back, and check it out. Give me a second. We shall return. Cold solder joints. That's all it was. Cold solder joints. Hello. It's 400 watts with 20 watts of drive from the 2950. Hello. Hello. 20 whole watts. Hello. Hello. When I came in here, I couldn't get it to do more than about maybe 75. It was just cold solder joints. So it was where the antenna wire met the board, and then where the variable met the board for the potentiometer. So hold on one second. Let's play with it. Love it when they're easy like this. Okay, so let's show you what we got going on. RCI 2950, 5 watt slug between the amplifier and of course 2950, 1000 watt slug and PEP, 1000 watt slug and average 5 watt slug, and reverse back from bird 10,000 watt dummy load. 20 whole watts of drive. Check this clackamas out.
Yes,
400 peak, 200 bird. Now, to pull this next little trick off, gotta make sure we got our variable all the way open, which we do. Shut that off. Let's hook up the 955. So 400 plus watts. Now let's hit this a little bit harder. Hello. Hello. Nice soft 80 watts. We're on 14 volts. Hello. 570, 580. Hello. 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 I don't want to key it too long because I don't want to have to tear this thing all apart and do a bunch of repairs on it, but this box will do it. It's a badass little thing, dude. It's a badass little box. Flippin' love these guys. So let's go back over here. Let's take the 955 out of the equation. Hook the 2950 back up. Hello. 500 watts again. Hello. So you hit it a whole lot harder and you get about 50 more watts out of it. Woohoo! Hello. 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 Done. Took a little bit to figure it out, but no problems. Put new power wires on it. And who am I working for? Call and talk with this guy. Hey, Joe. Thank you, man. I love these little guys. They're very precious little amplifiers. Take good care of this thing and it'll last you literally your lifetime and your children's lifetime. God knows it's already been around for most of my whole lifetime. Gentlemen, my name is BBI. With a shout of a doubt, I'm the biggest mud duck in Idaho. Come check us out. Facebook, Twitter, Snapchat, Instagram, and right here on the YouTube, Lidden Gargler. First time ever tuning in. Click subscribe. Joe, I gotta go. I'll give you a call tomorrow. Bump, bump.